Hello everyone. Today we'll study some applications of trigonometry ratios. First of all, let me review what we learned last class. Last class, we learned some special trigonometry values. Memorize table. Based on this table, we can find special trigonometry values for 30 degree, 45 degree, and 60 degree angles. For example, if we are looking for tension 30, tension is here, 30 degree is here. Tension 30 in the table is 1 over radical 3. If we are looking for cotension of 45 degree, cotension is here, 45 degree is here. Cotension 45 is 1 in the table. How about secant 60? Secant is here, 60 is here. Secant 60 in the table is 2. So, memorize this table. We can find special trigonometry values for 30 degree, 45 degree, and 60 degree angles. However, what if an angle is not one of these angles? What if an angle is not 30, not 45, not 60? Then how can we find the values? In this case, if an angle is not 30, 45, or 60, we have to use a calculator. Next, let me show you some examples. Evaluate each of the following trigonometry values using calculator. First example, sine of 20 degree. We know that 20 degree is not a special angle on the table. On the table, there's only 30, 45, 60. So 20 degree angle is not a special angle on the table. In this case, we must use calculator. In my calculator, sine of 20 is 0.3420. Usually, for trigonometry values, round to 4 decimal places. Next example, how about cosine 40? How about cosine 40 degree? Again, 40 degrees is not a special angle on the table. In this case, we must use calculator. In my calculator, cosine 40 degree is 0.7660, round to 4 decimal places. Next, how about tension 50? Again, 50 degree is not a special angle on the table. In this case, we must use calculator. In my calculator, I get 1.1918. Next, how about cotension 70? Again, 70 degree is not a special angle on the table. In this case, we must use calculator. But in many calculators, there's only sine, cosine, tension. What if there's no cotension in the calculator? If there's no cotension in the calculator, we must use trig identities. We know that cotension of theta is always 1 over tension theta. That's what we learned last class. Cotension of theta is always 1 over tension theta. Secant of theta is always 1 over cosine of theta. Cosecant of theta is always 1 over sine of theta. Because cotension and tension, they are reciprocals of each other. Secant and cosecant, they are reciprocals of each other. And cosecant and sine, they are reciprocals of each other. Cotension and tension, they are reciprocals of each other. Secant and cosine, they are reciprocals of each other. And cosecant and sine, they are reciprocals of each other. Keep this identity in mind. So, in your calculator, if there is cotension, we can find the value directly. But if there's no cotention, we must write it as 1 over tension 70. So, either evaluate cotension 70 or 1 over tension 70. We're going to say answer 0.3640. Next, how about secant 65? Again, 65 degree is not a special angle on the table. We must use calculator. In the calculator, if there is secant, you can find the value directly. But if there's no secant, we must write it as 1 over cosine 65 degree. Using this identity here. Secant theta is 1 over cosine theta. If there is secant, you can find the value directly. But if there's no secant in the calculator, we must write it as 1 over cosine 65. Then in your calculator, either evaluate secant 65 or 1 over cosine 65. We get the same answer, 2.3662. In the calculator, either evaluate secant 65 or 1 over cosine 65. We get the same value, 2.3662. Next, how about cosecant 85? Again, 85 degree is not a special angle on the table, so we must use calculator. In your calculator, if there is cosecant, you can find the value directly. In your calculator, if there's no cosecant, we must write it as 1 over sine theta. Write it as 1 over sine 85. Then in your calculator, either evaluate cosecant 85 or 1 over sine 85. We get the same answer, 1.0039. That's how we evaluate trigonometry values that's not on the table. Next, let's practice applications about trigonometry ratios. First example, in the following right triangle, find angle B and sides B and C. In this triangle here, that's angle A, that's angle B, that's angle C. That's side A, side B, and side C. Usually, the opposite side of angle A is side A. The opposite side of angle B is side B. And the opposite side of angle C is side C. Here we know that angle A is 30 degrees. Angle C is a right angle. Side A is 4. We're looking for angle B, side B, and side C. Let's find angle B first. What's angle B? We know that angle A and angle B, they are complementary angles, which means angle A plus angle B is 90 degrees. So angle B can be written as 90 degrees minus angle A. Since angle A and angle B, they are complementary angles, that means if I add angle A to angle B, I get 90 degrees. Angle A plus angle B is 90 degrees. So angle B can be found by using 90 degrees minus angle A. Angle A here, we know is 30 degrees. 90 minus 30 is 60. So angle B is 60 degree angle. Next, let's find side B. How can we find side B? We know angle A is 30 degrees here. That's an opposite side. Refer to angle A, that's an opposite side. B is an adjacent side. Refer to angle A, that's an opposite side. That's an adjacent side. If we try to write opposite and adjacent together, what function should we use? What trigonometry function should we use? That's an opposite side. That's adjacent side. If we try to write adjacent and opposite together, we know that tangent of angle is always adjacent over opposite. Tangent of angle is always adjacent over opposite. If we try to put adjacent, opposite, and adjacent together, we can use tangent theta. So we know that tangent of A is an opposite over adjacent. That's A over B. So using tangent, I can write A and B together in one equation. Using tangent of A, I can write A and B together in one equation. Then plug in. We know that angle A is 30 degrees. Side A is 4. We are looking for B. Then here, tangent of 30 degrees. 30 degrees is a special angle. We know that tangent of 30 is 1 over radical 3. Tangent of 30 is 1 over radical 3. That's a special angle. That's a special value. Tangent 30 degrees is 1 over radical 3. And we are solving for B. Here I can cross multiply. If I cross multiply, I get 1b equal to 4 radical 3. So here b is 4 radical 3. Now, how about side C? How can we find C? Let's start over. We know that refer to angle A. We know its opposite side is 4. C is adjacent side. We know the opposite, and we are looking for adjacent. Using what function we can write opposite and adjacent together? Using what function we can write opposite and adjacent together? If we try to write opposite and adjacent together, we can try to use sine. We know that sine theta is always opposite over hypotenuse. If we try to put opposite and hypotenuse together, we can use sine function. Sine of an angle is always opposite over hypotenuse. That's opposite. C is hypotenuse. So if I try to write A and C together in one equation, I use sine of A. Sine of A is opposite over hypotenuse, A over C. We know that angle A is 30 degrees. Sine A is 4. We're looking for C. And here, we know sine 30 is a special value. Sine 30 in the table is 1 over 2. So 1 over 2 equal to 4 over C. Next, I can cross multiply. I get C equal to 2 times 4 is 8. C equal to 8. So we found angle B is 60. Side B is 4 radical 3. Side C is 8. That's how we find angle B and side B and side C. In general, if we try to write adjacent and opposite together in one equation, we use tension. If we try to write opposite and hypotenuse together, we use sine. If we try to write adjacent and hypotenuse together, we use cosine. So we can memorize as so cut TOA. If we try to write opposite and hypotenuse together, use sine. If we try to write adjacent and opposite and hypotenuse together, use cosine. If we try to write opposite and adjacent together, use tension. So I can memorize as so cut TOA. If we try to write opposite and hypotenuse together, use sine. If we try to write adjacent and hypotenuse together, use cosine. If we try to write opposite and adjacent together, use tension. Next, let's try more examples. Next example. In the following right triangle, find angle A and side A and side B. The triangle looks like this. That's a right angle. That's angle A. That's angle B. That's angle C. This is side A. This is side B. And this is side C. Side C is 6. Angle B is 45-degree angle. Find angle A, side A, and side B. Let's find angle A first. How can we find angle A? Since angle A and angle B, they are complementary angles, which means angle A plus angle B must be 90 degrees. So angle A can be written as 90 degrees minus angle B, which is 90 degrees minus 45 degrees, which is 45 degrees. So angle A is 45 degrees. Next, find side A and side B. Let's find side A first. Side A is here. Refer to angle B. Side A is adjacent. Side C, we know side C. Side C is hypotenuse. So if we try to write adjacent and hypotenuse together, we use cosine. If we try to write adjacent and hypotenuse together, use cosine. Cosine is adjacent over hypotenuse. So cosine of angle B is adjacent over hypotenuse, A over C. Then plug in. Angle B is 45 degrees. We don't know side A, but we know that side C is 6. Here, 45 degree is a special angle on the table. Cosine 45 is 1 over radical 2. Cosine 45 is 1 over radical 2. Here, we are looking for A. So I can cross multiply. If I cross multiply, I get radical 2 times A equal to 6. In order to get A by itself, I divide both sides by radical 2. So A equal to 6 over radical 2. And in general, for the final answer, we need to rationalize the denominator. So if there's square root on the denominator, I multiply both top and bottom by square root of 2. Then together, on the top, I get 6 times square root of 2 on the top. On the bottom, square root of 2 times square root of 2 is 2. So the top is 6 square root of 2. Bottom is 2. Then 6 divided by 2 is 3. The final answer is A equal to 3 square root of 2. The final answer is A equal to 3 square root of 2. Next, let's try to find side B. Refer to angle B here. That's an opposite. That's an opposite side. We know the hypotenuse. If we try to write opposite and hypotenuse together, I use sine. If we try to write opposite and hypotenuse together, use sine. We know that sine of angle is opposite over hypotenuse. So sine of angle B is opposite over hypotenuse, B over C. And we know that angle B is 45 degree. Angle B is 45 degree. We don't know side B. We're looking for side B. Side C is 6. Here, sine 45 is a special angle. That's a special value. In the table, sine 45 is 1 over radical 2. 1 over radical 2 is B over 6. We're looking for B, so I can cross multiply. I get radical 2 times B equal to 6. Then I can divide both sides by radical 2. B equal to 6 over radical 2. In general, for the final answer, we need to rationalize the denominator. So multiply top and bottom by radical 2. I get 6 radical 2 over 2. And then 6 divided by 2 is 3. It turned out B is 3 radical 2. So that's how we find angle A, side A, and side B. Next example. In the following right triangle, find angle B and sides A and C. In this right triangle here, that's angle A, B, C. That's sides A, B, and C. Here, angle A is 25 degree. Angle C is a right angle. And side B is 10. We try to find angle B and sides A and C. Let's find angle B first. We know that since angle C is a right angle, angle A and B, they're called complementary angles, which means angle A plus angle B is 90 degree. So for angle B, we can use 90 degree minus angle A. Since angle A plus angle B is 90 degree, so for angle B I use 90 degree minus angle A. And we know that angle A is 25 degree. 90 degree minus 25 degree is 65 degree. That's angle B. Next, we try to find sides A and C. Let's find side A first. Here, refer to angle A. Side A is an opposite side. Side B is adjacent side. That's opposite, that's adjacent. And here, keep this relationship in mind. SOHCAHTOA. Here we have opposite and adjacent. we use tension. When we try to find a relationship between opposite and adjacent, use tension. Tension of angle A is opposite over adjacent, A over B. So when we try to write opposite and adjacent in one equation, use tension. Here, angle A is 25 degrees. We don't know side A, but we know side B is 10. Then solve the equation for A. Here, I can multiply both sides by 10. If I multiply both sides by 10, I get A equal to 10 times tension 25 degrees. And here we know that 25 degrees is not one of the special angles. 25 degrees is not one of these special angles. So here we must use calculator. For tension 25 degrees times 10. In my calculator, I get 4.66. Take 10 times tension 25 degrees. In my calculator, I get 4.66. That's side A. Next, let's find side C. We know angle A. We know side B. That's an adjacent side. C is hypotenuse. When we try to write adjacent and hypotenuse together in one equation. Adjacent, hypotenuse together in one equation, I use cosine. When we try to write adjacent and hypotenuse together in one equation, we use cosine. So cosine A is adjacent over hypotenuse, B over C. Then plug in. We know that angle A is 25 degrees. Side B is 10. We're looking for side C. Here I can first of all multiply both sides by C. I get C times cosine 25 degrees equal to 10. Then I can divide both sides by cosine 25 degrees. Next, divide both sides by cosine 25 degrees. Then, since cosine 25 is not one of the special angles, 25 degrees is not one of the special angles, we must use calculator here. So use calculator, take 10 divided by cosine 25 degrees. In my calculator, I get 11.03. So that's side A and side C. Next example. In the following right triangle, find angle A and sides A and B. In this triangle here, that's angle A, angle B, angle C. That's side A, side B, and side C. Here, angle B is 50 degrees. Angle C is a right angle. We don't know sides A and B, but side C is 12. We are looking for angle A and sides A and B. Let's find angle A first. Since angle C is a right angle, angles A and B, they are called complementary angles. That means the sum of angle A and angle B is 90 degrees. So angle A can be written as 90 degrees minus angle B. Since angle A plus angle B is 90 degrees, so for angle A I can use 90 degrees minus angle B. Here angle B is 50 degrees. 90 degrees minus 50 degrees is 40 degrees. That's angle A. Next, let's try to find sides A and B. Let's find side A first. Refer to angle B here. We know the hypotenuse. Side A is adjacent side. We know the hypotenuse. Side A is adjacent side. When we try to write adjacent and hypotenuse together in one equation, adjacent hypotenuse together in one equation, we use cosine. So cosine of angle B is adjacent over hypotenuse, A over C. Then plug in. We know angle B is 50 degrees. We don't know side A, but we know side C is 12. We are solving the equation for side A. Since we don't know cosine 50, we must use calculator here. Since we don't know cosine 50 is not a special angle. 50 degrees is not a special angle. We must use a calculator here. So here I can first of all multiply both sides by 12. If I multiply both sides by 12, I get A by itself. A equal to 12 times cosine 50 degree. Then use calculator. Use 12 times cosine 50. In the calculator, do 12 times cosine 50. I get 7.71 in my calculator. Use 12 times cosine 50. Since cosine 50 is not a special angle. If an angle is not 30, 45, or 60, we must use calculator to find the values. So here, side A is 7.71. Next, let's try to find side B. Refer to angle B here. Side B is an opposite side, and we know the hypotenuse. When we try to write opposite and hypotenuse in one equation, opposite hypotenuse in one equation, we use sine. So when we try to write opposite and hypotenuse together in one equation, we use sine. Sine of angle B is opposite over hypotenuse. Sine of angle B is opposite over hypotenuse. Sine of B equal to B over C. Opposite over hypotenuse, B over C. Then plug in the values. The angle B is 50 degrees. We don't know side B, but we know side C is 12. We have to solve an equation for B. Here I can multiply both sides by 12. If I multiply both sides by 12, I get B equal to 12 times sine 50. Since sine 50 is not a special angle, that's not a special angle, we must use calculator. So use calculator, take 12 times sine 50. In my calculator, I get 9.19. Take 12 times sine 50. In my calculator, I get 9.19. So that's sides A and B. Next example. A tree casts a shadow of 200 feet. If an angle of elevation of the sun is 35 degrees, what is the height of the tree? Let's draw a rough graph first. A tree casts a shadow of 200 feet. Assume that's a tree. I don't know how tall it is. Assume that's a tree. I don't know how high it is. That's a tree. Assume that's the shadow of the tree. The sun is here. Assume the sun is here. That's the shadow of the tree. If an angle of elevation of the sun is 35 degrees, now angle of elevation, that's the angle above horizontal. That's an angle above horizontal. That's called angle of elevation. So if an angle is above horizontal, this is called the angle of elevation. Assume that's the horizontal. If an angle is above horizontal, that's called an angle of elevation. If an angle is above horizontal, this angle is called an angle of elevation. And on the other side, if an angle is below horizontal, if an angle is below horizontal, that's called an angle of depression. That's called an angle of depression. An angle above horizontal is called an angle of elevation. If an angle is below horizontal, that's called angle of depression. Here, the angle of elevation of the sun is 35 degrees. So the angle above horizontal is 35 degrees. That's an angle of elevation. And the shadow of the tree is 200 feet. That's a right angle. We are looking for the height of the tree. So We don't know the height of the tree. Let's call this side x. We don't know how high it is. Let's call this side x. Refer to this angle. That's the opposite side. That's the adjacent side. If we try to write opposite and adjacent together in one equation, we try to use tension. When we try to write opposite and adjacent together in one equation, we use tension. So we know that tension of 35 degrees, tension of this angle, is opposite over hypotenuse, x over 200. Opposite over adjacent, that's tension. Opposite over adjacent, x over 200, that's opposite over adjacent. We are solving for x, so I can cross multiply. So I can multiply both sides by 200. So to get x by itself, I can multiply both sides by 200. I get x equal to 200 times tension of 35 degrees. Then use calculator. Since 35 degrees is not a special angle, we must use calculator. 35 degrees is not a special angle, we must use calculator. In my calculator, 200 times tension 35 degrees, I get 140.04. 140.04. The unit here is feet. Unit here is feet. So x equal to 140.04 feet. That's the height of the tree. That's the height of the tree. Next example. Assume the height of a lighthouse is about 100 feet. On the top of the lighthouse, a bow is observed with an angle of depression of 25 degrees. What is the distance from the bow to the bottom of the lighthouse? So let's draw a rough graph first. Assume the height of a lighthouse is 100 feet. Assume that's a lighthouse. The height of the lighthouse is about 100 feet. That's the height of the lighthouse. It's about 100 feet. On the top of the lighthouse, it's the top of the lighthouse. A bow is observed. So that's the sea level. A boat is observed. Assume that's the boat. So on the top of the lighthouse, a boat is observed with an angle of depression of 25 degrees. Angle of depression is angle below horizontal. So on the top of the lighthouse, that's an horizontal. On the top of the lighthouse, that's an horizontal. The angle of depression is an angle below horizontal. That's 25 degree angle. That's an angle of depression. That's an angle below horizontal. What is the distance from the boat to the bottom of the lighthouse? We're looking for the distance from the boat to the bottom of the lighthouse. We're looking for this side. That's a right angle. We know the height of the lighthouse is 100 feet. We're looking for the distance from the boat to the bottom of the lighthouse. That's the angle of depression is 25 degrees. How can we find x here? We know that this angle and this angle, they are congruent angle. They are the same. This angle 25 and this angle, they are congruent angle. This angle and this angle, they are exactly the same. This is also 25 degree angle. Then in this right triangle, we know this angle here. Refer to this angle. That's 100. 100 here is the opposite side. X is adjacent side. If we try to write opposite and adjacent together in one equation, we use tension. So tension of this 25 degree angle. Tension 25 is opposite over adjacent. Tension 25 is opposite over adjacent. 100 over x. We are solving the equation for x. So in order to solve for x, I can first of all multiply both sides by x. If I multiply both sides by x, I get x times tension 25 degree equal to 100. Then I can divide both sides by tension 25 degree. S equal to 100 over tangent 25 degree. And again, 25 degree is not special angle. We must use calculator. 25 degrees is not special angle. We must use calculator here. In my calculator, 100 divided by tangent 25 degree is 214.45 feet. That's the distance from the boat to the bottom of a lighthouse. Next, let me show you how to find more special trigonometry values. First of all, let me introduce positive and negative angles. Consider an angle. Let's call the vertex. We call one of the sides to be the initial side. And we call the other side to be the terminal side. So we measure an angle from initial side to the terminal side. That's how we measure this angle here. We measure an angle from initial side to the terminal side. If we measure an angle counterclockwise, the angle is positive. If we measure an angle counterclockwise, this angle is positive. Here we measure an angle counterclockwise, this angle is positive. If an angle is measured counterclockwise, then the angle is positive. Another example. Consider this angle. That's the vertex. That's the initial side. And that's the terminal side. We measure an angle counterclockwise. That's initial, that's terminal. If we measure an angle counterclockwise, this angle is positive. So those are two positive angles. Another example. Consider this angle. Assume the initial side is here. And the terminal side is here. We measure an angle from initial side to the terminal side. Here we measure this angle clockwise. If we measure angle clockwise, then the angle is negative. So if an angle is measured clockwise, then the angle is negative. If an angle is measured clockwise, then angle is negative. Here, for this angle is measured clockwise. This angle is measured clockwise. Vertex is here. It's measured clockwise. So this angle is negative. Another example. Assume that's the initial side. That's the terminal side. That's the vertex. So we measure the angle from initial side to terminal side. If we measure angle clockwisely, this angle is negative. So those are two examples of positive angles. Those are two examples of negative angles. If we measure an angle counterclockwise, the angle is positive. If we measure an angle clockwise, the angle is negative. This direction is called counterclockwise. This direction is called counterclockwise. This direction is called clockwise. Next, let me introduce the standard position of angles in the xy plane. Standard position of angles in the xy plane. For angle in the xy plane, if its vertex is in origin, and its initial side is in a positive x-axis, then we say an angle is in the standard position in the xy plane. So consider xy plane. That's the x-axis. That's the y-axis. The intersection is origin. For any angle, if its initial side is in the positive x-axis, its vertex is in the origin, initial side is in the positive x-axis, then we say this angle is in the standard position in the xy plane. Those are examples of angles in the standard position. Its vertex is in the origin. Initial side is in the positive x-axis. This is the x-axis. That's the positive x-axis. If its initial side is in the positive x-axis, then we say an angle is in the standard position in the xy plane. That's a very special angle. That's the initial side. That's the terminal side. And we measure the angle counterclockwise. That's angle theta. Consider this angle. That's the initial side. That's the terminal side. We measure the angle counterclockwise. This is angle theta. That's initial side. That's terminal side. That's angle theta. So those are 4 positive angles in a standard position in the xy plane. Those are 4 positive angles in the standard position in the xy plane. Note, for angle in the xy plane, if its terminal side is located in the quadrant, there are 4 quadrants: quadrant 1, quadrant 2, quadrant 3, quadrant 4. If the terminal side of angle is in one of these quadrants, is in a quadrant, then we say the angle lies on the quadrant. Then we say the angle lies on the quadrant. Or the angle belongs to the quadrant. For example, in the first picture, the terminal side of the angle lies on quadrant 1. So we say angle theta belongs to quadrant 1. So here we say, for this angle theta belongs to quadrant 1. Here we use Q1 to represent quadrant 1. For the second angle here, its terminal side is in quadrant 2. So then this angle theta lies on quadrant 2, or angle theta belongs to quadrant 2. Here we say angle theta belongs to quadrant 2. We use Q2 to represent quadrant 2. For this example here, the terminal side of an angle lies on quadrant 3. The terminal side of angle theta lies in quadrant 3. So we say angle theta lies on quadrant 3, or belongs to quadrant 3. And for this angle here, that's the initial side. That's the terminal side. Angle theta here belongs to quadrant 4. Here the terminal side is in quadrant 4. So we say angle theta belongs to quadrant 4. Q4 represents quadrant 4. So if the terminal side of an angle belongs in quadrant 1, lies on quadrant 1, we say angle theta belongs to quadrant 1. If the terminal side of an angle is in quadrant 2, we say an angle belongs to quadrant 2. If the terminal side of an angle lies on quadrant 3, we say an angle belongs to quadrant 3. If the terminal side of an angle is in quadrant 4, we say an angle belongs to quadrant 4, or it lies on quadrant 4. Next, let's look at some examples. Draw each of the following angles in the standard position in the xy plane. First example, 45-degree angle. How can we draw a 45-degree angle in the standard position in the xy plane? That's an xy plane. That's an origin. For a 45-degree angle in the standard position, its vertex must be in origin, and its initial side must be in the positive x-axis. So that's the vertex. That's the initial side. Since an angle is positive, we measure an angle counterclockwise by 45 degrees. Measure an angle counterclockwise by 45 degrees. That's the terminal side. That's the 45-degree angle in the standard position in the XY plane. This is a 45-degree angle in the standard position in the XY plane. Next example, 120 degree. How can we draw a 120-degree angle in the standard position in the XY plane? For 120-degree angle in the standard position, its vertex must be in the origin. Its initial side must be in the positive x-axis. So that's the vertex, that's the initial side. The angle is positive, so we measure the angle counterclockwise by 120 degrees. 120 degrees is more than 90. That's the terminal side. So this is a 120-degree angle in the standard position in the XY plane. This angle here, that's a 120-degree angle in the standard position in the XY plane. Next example, 210 degree. For 210-degree angle in the standard position in the XY plane, its vertex must be in the origin. Its initial side must be in the positive x-axis. So that's the vertex, that's the initial side. Since the angle is positive, we measure the angle counterclockwise by 210 degrees. 90 is here, 180 is here. 210 is a little more than 180. $90, 180, 210. 210 is a little more than 180. So that's a 210-degree angle in the standard position in the XY plane. This angle is 210-degree angle in the standard position in the XY plane. Here we can see that this angle terminates in quadrant 1. So this angle, 45-degree angle, belongs to quadrant 1. 120-degree angle terminates in quadrant 2. So this angle belongs to quadrant 2. 210-degree angle terminates in quadrant 3. So this angle belongs to quadrant 3. Next, how about 315-degree angle? How can we draw a 315-degree angle in the standard position? First of all, its vertex must be in the origin. Its initial side must be in the positive x-axis. So that's the vertex of an angle, that's the initial side. Angle is positive, so we measure the angle counterclockwise this way. 90 is here, 180 is here, 270 is here. 315 is more than 270. So this is the 315-degree angle. This is a 315-degree angle in the standard position in the XY plane. That's the initial side. That's the terminal side. Here we can see that 45-degree angle belongs to quadrant 1. 120-degree angle belongs to quadrant 2. $210-degree angle belongs to quadrant 3. And 315-degree angle belongs to quadrant 4. So here we can see that if an angle is between 0 and 90 degrees, it belongs to quadrant 1. If an angle is between 90 and 180, it belongs to quadrant 2. If angle is between 180 and 270, it belongs to quadrant 3. If angle is between 270 and 360, it belongs to quadrant 4. So note, if an angle theta is between 0 and 90 degrees, Then theta belongs to quadrant 1. Theta belongs to quadrant 1. If angle theta is between 90 and 180 degrees, then theta belongs to quadrant 2. If theta is between 180 and 270, then theta belongs to quadrant 3. And if theta is between 270 and 360, then theta belongs to quadrant 4. Next, let me show you more examples. Example 5. How can we draw the 405-degree angle in the standard position? How can we draw 405-degree angle in the standard position? For angle in the standard position, its vertex must be in the origin. Its initial side must be in the positive x-axis. That's the vertex. That's the initial side. Next, measure the angle by 405 degrees. 90 is here, 180 is here, 270 is here, 360 is here. If we keep going, 360 plus 90 is 450. So 405 is between 360 and 405 and 450. So 405 is somewhere here. 0, 90, 180, 270, 360, 450. 360 plus 90 is 450. That's too big. So the 405-degree angle terminates here. The 405-degree angle terminates here. That's the initial side. That's the terminal side. That's the 405-degree angle in the standard position. That's the initial side. That's the terminal side. Next example, how can we draw 480-degree angle in the standard position? For 480-degree angle in the standard position, its vertex must be in the origin. Its initial side must be in the positive x-axis. So that's the vertex. That's the initial side. Then 480 degree is positive angle. Measure the angle by 480 degree. 0 is here, 90 is here, 180 is here, 270, 360. 480 is more than 360. 450 is here. 360 plus 90 is 450. 480 is more than 450. 450 plus 90 is 540. 480 is less than 540, so it should be here. So that's the terminal side. Initial side is here, terminal side is here. 0, 90, 180, 270, 360, eventually reach 480. That's the 480-degree angle. This angle terminates in quadrant 2. This angle terminates in quadrant 1. Next, how about negative 150-degree angle? How can we draw this negative angle in the standard position? How can we draw this negative angle in the standard position? For angle in the standard position, its vertex must be in origin. Its vertex must be in origin. Its initial side must be in the positive x-axis. Its initial side must be in the positive x-axis. Now, since an angle is negative, we measure an angle clockwise. Since an angle is negative, we measure an angle clockwise. 0 is here, that's negative 90, negative 180. Measure an angle counterclockwise. Measure an angle clockwise by 150 degrees. This is negative 150 degree angle. This angle belongs to quadrant 3. Its terminal side is in quadrant 3. This angle belongs to quadrant 3. Next, how about negative 45 degree angle? Again, this angle is negative. For angle in the standard position, its vertex must be in the origin. Its initial side must be in the positive x-axis. Since the angle is negative, we measure the angle clockwise. Measure the angle clockwise by 45 degrees. So that's the terminal side. This is the negative 45 degree angle. That's the initial side, that's the terminal side. This angle belongs to quadrant 4. So here you can see that 405 degree angle belongs to quadrant 1. 480 degree angle belongs to quadrant 2. And negative 150 degree belongs to quadrant 3. Negative 150 degree belongs to quadrant 3. And negative 45 degree angle belongs to quadrant 4. Next, let's observe these angles. If we observe these angles, 45 degree angle and 405 degree angle, you can see that these two angles, they terminate in the same position. They have the same terminal side. These two angles have the same initial side and the same terminal side. These two angles, example 2 and example 6, they have the same initial side and the same terminal side. This is two examples, example 3 and example 7, they have the same initial side, same terminal side. And same thing in example 4 and 8. These two angles, they have the same initial side, same terminal side. In this case, they are called coterminal angles. If angles in the standard position has the same initial side and the same terminal side, they are called coterminal angles. Coterminal angles. For two angles in the standard position, in the XY plane, if they have the same initial side and terminal sides, if they have the same initial side and terminal sides, they are called coterminal angles. If two angles have the same initial side and the same terminal side, they are called coterminal angles. So these two angles, they are called coterminal angles. These two angles, they are called coterminal angles. These two angles, they are called coterminal angles. And these two angles, they are called coterminal angles. And here we can see that the difference between coterminal angles here, what's the difference? 405 minus 45 is 360. 480 minus 120 is also 360. 210 minus negative 150. 210 minus negative 150. Double negative is positive. 210 plus 150 is also 360. 315 minus negative 45. 315 minus negative 45. Double negative is positive. 315 plus 45 is also 360. So the difference between coterminal angles is always 360 or multiples of 360. Since a complete cycle is 360. Since a complete cycle is 360, The difference between two coterminal angles is either 360 or multiple of 360. Note. The difference between two coterminal angles is always 360 degrees. Or multiple of 360 degrees. Since a complete cycle is 360 degrees, so the difference between coterminal angles is either always 360 degrees or a multiple of 360 degrees. Next, let's look at some examples. For each of the following angles, find its coterminal angle on the interval from 0 to 2 pi, and then determine what quadrant is an angle located. So this interval here, from 0 to 2 pi, what does it mean? The interval 0 to 2 pi, if there's no units, it means radian measure. We know that 0 radian is the same as 0 degree. How about 2 pi radian? We know pi is 180 degree. 2 times 180 is 360 degree. So the interval from 0 to 2 pi is the same as the interval from 0 to 360. Bracket means 0 is included. Parentheses means 360 is not included. So for each of the following angles, find coterminal angles on the interval from 0 degree to 360 degree, and then determine what quadrant is an angle located. If the angle is between 0 degree and 90 degree, it's located in quadrant 1. If angle is between 90 degree and 180 degree, angle is located in quadrant 2. If angle is between 180 degree and 270 degree, the angle is located in quadrant 3. And if angle is located in between 270 degree and 360 degree, angle is located in quadrant 4. 360 go back to 0. They are the same. So if angle is between 270 and 360, the angle is located in quadrant 4. So between 0 and 90 is in quadrant 1. Between 90 and 180 is in quadrant 2. Between 180 and 270 is in quadrant 3. Between 270 and 360 is in quadrant 4. First example, 420 degree. 420 is more than 360. We try to find coterminal angle between 0 and 360. So if 420 is more than 360, take 420 minus 360. Since the difference of coterminal angle is either 360 or multiples of 360. 420 is more than 360, so I take 420 minus 360. I get 60. That's the coterminal angle between 0 and 360. And this angle terminates in quadrant 1. This angle is in quadrant 1. 60 degrees is between 0 and 90 is in quadrant 1. So 420 degrees belong to quadrant 1. Next example. How about 495 degrees? 495 degrees is more than 360. So subtract by 360. If angle is more than 360, in order to find coterminal angle between 0 and 360, subtract angle by 360. 495 minus 360 is 135 degrees. 135 degrees is between 0 and 360. So that's the coterminal angle between 0 and 360. And we know that 135 is between 90 and 180. 135 is between 90 and 180. So this angle, 495, terminates in quadrant 2. 495 terminates in quadrant 2. Next example. How about 960? 960 degree is more than 360. So in order to find a coterminant angle between 0 and 360, we subtract this angle by 360. If I take 960 minus 360, the angle is 600, which is still more than 360. So keep subtracting, because we know that the difference between any two coterminant angles is either 360 or multiples of 360. So we may subtract the angle by 360 multiple times. Take 600 minus 360. I get 240 degree. And we can see that 240 is between 180 and 270. That's in quadrant 3. So 960 degree terminates in quadrant 3. Because 240 terminates in quadrant 3. This is a coterminant angle. It terminates in the same position. Next, 1380 degree. This angle is more than 360. In order to find a coterminant angle between 0 and 360, keep subtracting the angle until it's between 0 and 360. Take 1380 minus 360. I get 1020 degree. That's more than 360. So keep subtracting the angles. Take 1020 degree minus 360. That's 660, which is still more than 360. It's still more than 360. So keep subtracting. Take 660 minus 360. I get 300 degree. This angle 300 is between 0 and 360. So that's the coterminant angle of 1380 between 0 and 180. That's the coterminant angle of 1380 degree between 0 and 360 degree. And we know 300 is between 270 and 360. It terminates in quadrant 4. So 1380 degree angle terminates in quadrant 4. It belongs to quadrant 4. Next example. How about negative 300? How about negative 300 degree? If an angle is negative, we try to find its positive coterminant angle first. If angle is negative, we know that for coterminant angle between 0 and 360, it must be positive. And the difference between coterminant angles is either 360 or multiples of 360. Instead of subtracting, I can keep adding number by 360. If I take 300, negative 300 plus 360 degree, what do we get? Negative 300 plus 360 is positive 60 degree. We know that 60 degree is between 0 and 190. That belongs to quadrant 1. Since 60 degree belongs to quadrant 1, negative 300 is a coterminant angle. It also belongs to quadrant 1. So negative 300 degree angle belongs to quadrant 1. Next, how about negative 240 degree? If angle is negative, we keep adding 360 until it's between 0 and 360. So take negative 240 plus 360 degree. I get positive 120 degree. That's the coterminant angle of negative 240. We know that 120 degree is between 90 and 180. So it belongs to quadrant 2. So negative 240 degree angle belongs to quadrant 2. Next, how about negative 510 degree? In order to find a coterminant angle between 0 and 360, for negative angle, we keep adding 360 until it becomes positive. For negative angle, keep adding 360 until it becomes positive. Take negative 510 degree. If I add 360 degree, what do we get? Negative 510 plus 360 is negative 150. It's still negative. Keep adding until it becomes positive. Take negative 50 plus 360. I get positive 210. And we know that 210-degree angle is between 180 and 270. It located in quadrant 3. Since 210 located in quadrant 3, negative 510 is a coterminal angle. It's also located in quadrant 3. So negative 510 degree also belong to quadrant 3. Next, how about negative 750? If the angle is negative, keep adding 360 until it becomes positive. If the angle is negative, keep adding 360 until it becomes positive. Take negative 750 plus 360. We get negative 390 degree, which is still negative. So keep adding 360. Negative 390 plus 360 is negative 30. It's still negative. Keep adding 360. We get 330 degree. Now it becomes positive. This angle is between 270 and 360. So 330 is belong to quadrant 3, belong to quadrant 4. 330 belong to quadrant 4. 330 degree belong to quadrant 4. And since negative 750 is the coterminal angle, it also terminates in quadrant 4. So negative 350 terminates in quadrant 4. Since 330 terminates in quadrant 4, its coterminal angle also terminates in quadrant 4. Next example. How about the angle is 7 pi over 3? How about the angle is 7 pi over 3? How can we find its coterminal angle between 0 and 2 pi? First of all, is 7 pi over 3 more than 2 pi? What's 2 pi? 2 pi can be rewritten as 6 pi over 3. Here we can see that 7 pi over 3 is more than 2 pi. So if the angle is more than 2 pi, for its coterminal angle between 0 and 2 pi, take this angle minus 2 pi. So I take 7 pi over 3 minus 2 pi. We know that 2 pi is 6 pi over 3. So 7 pi over 3 minus 6 pi over 3 is pi over 3. And we know that pi over 3 is between 0 and 2 pi. Pi over 3 is between 0 and 2 pi. So that's the coterminal angle between 0 and 2 pi. Now, what quadrant does pi over 3 locate in? What quadrant does pi over 3 locate? We know that 0 degree, if I change to radian, that's 0 radian. If I change 90 degree to radian measure, 90 degree is pi over 2 radian. 180 is pi. 180 degree is pi radian. 270 degree, if we change to radian measure, that's 3 pi over 2 radian. And 360 degree is 2 pi. 2 pi radian go back to 0. And here we can see that pi over 3 is between 0 and pi over 2. So pi over 3 is in quadrant 1. We use Q1 to represent quadrant 1. If angle is between 0 and pi over 2, it's in quadrant 1. If angle is between pi over 2 and pi, it's in quadrant 2. If angle is between pi and 3 pi over 2, it's in quadrant 3. If angle is between 3 pi over 2 and 2 pi, it's in quadrant 4. Next example. 29 pi over 6 finds coterminal angle. 29 pi over 6 finds coterminal angle. First of all, is 29 pi over 6 more than 2 pi? How much is 2 pi? 2 pi, if I try to put it over 6, 2 pi can be rewritten as 12 pi over 6. If I try to put 2 pi over 6, it can be rewritten as 12 pi over 6. Here we can see that 29 pi over 6 is more than 2 pi. It's more than 2 pi over 6. If the angle is more than 2 pi, take the angle minus 2 pi. For coterminal angle, their difference is always 2 pi or multiples of 2 pi. So if an angle is more than 2 pi, keep subtracting the angle by 2 pi until it becomes less than 2 pi. 29 over 6 minus 2 pi. 2 pi is 12 pi over 6. So 29 pi over 6 minus 12 pi over 6 is 17 pi over 6. 17 pi over 6 is still more than 2 pi. So keep subtracting until it becomes less than 2 pi. Next, take 17 pi over 6 minus 2 pi. 17 pi over 6 minus 2 pi. 2 pi is 12 pi over 6. So 17 pi over 6 minus 12 pi over 6 is 5 pi over 6. Here we can see that 5 pi over 6 is less than 2 pi. 5 pi over 6 is less than 2 pi. So that's the coterminal angle between 0 and 2 pi. That's the coterminal angle between 0 and 2 pi. Next question. What quadrant does 5 pi over 6 locate? What quadrant does 5 pi over 6 locate? 5 pi over 6 is between pi over 2 and pi, because pi over 2 can be rewritten as 3 pi over 6. I multiply top and bottom by 3. Pi over 2 can be rewritten as 3 pi over 6. And pi can be rewritten as 6 pi over 6. Here we can see that 5 pi over 6 is between pi over 2 and pi. It's between 3 pi over 6 and 6 pi over 6. 5 pi over 6 is between pi over 2 and pi. Because pi over 2 can be rewritten as 3 pi over 6. Pi by itself can be rewritten as 6 pi over 6. And 5 pi over 6 is between 3 pi over 6 and 6 pi over 6. So 5 pi over 6 is in quadrant 2. If 5 pi over 6 is quadrant 2, that means this angle, the coterminal angle, 29 pi over 6 is in quadrant 2. In the previous question, since pi over 3 is in quadrant 2, we have 7 pi over 3 is in quadrant 2, is in quadrant 1. Since pi over 3 is in quadrant 1, 7 pi over 3 is also in quadrant 1. Next, how about negative 3 pi over 4? What's the coterminal angle of this angle? Negative 3 pi over 4. If the angle is negative, keep adding 2 pi until it becomes positive. How much is 2 pi? If you try to write 2 pi over 4, how much is 2 pi? 2 pi can be rewritten as a pi over 4. A pi over 4 is 2 pi. So first of all, try to write 2 pi over 4. So 2 pi can be rewritten as a pi over 4. Then if angle is negative, keep adding 2 pi until it becomes positive. So take negative 3 pi over 4 plus 2 pi. 2 pi is a pi over 4. Negative 3 pi over 4 plus a pi over 4 is 5 pi over 4. And 5 pi over 4 is between 0 and 2 pi. That's the coterminal angle. Now, how much is 5 pi over 4? We know that pi can be rewritten as 4 pi over 4. 3 pi over 2, if I multiply top and bottom by 2, I can make 6 pi over 4. We can see that 5 pi over 4 is between 4 pi over 4 and 6 pi over 4. So 5 pi over 4 is in quadrant 3. Since 5 pi over 4 is in quadrant 3, its coterminal angle, negative 3 pi over 4, is also in quadrant 3. So negative 3 pi over 4 is in quadrant 3. Next example. How about negative 7 pi over 6? What's the coterminal angle of this angle? And what quadrant does it locate? First of all, this angle is negative. If angle is negative, keep adding 2 pi until it becomes positive. If angle is negative, keep adding 2 pi until it becomes positive. How much is 2 pi? If we write 2 pi over, if we try to write 2 pi over 6, 2 pi can be rewritten as 12 pi over 6. So for negative 7 pi over 6, if I add 2 pi, 2 pi is 12 pi over 6. Negative 7 pi plus 12 pi is 5 pi over 6. So that's the coterminal angle. Since 5 pi over 6 is between 0 and 2 pi, that's the coterminal angle. But what quadrant does it locate? What quadrant does it locate? We know that pi over 2, if I multiply top and bottom by 3, it can be rewritten as 3 pi over 6. Pi by itself, if I try to put it over 6, pi can be rewritten as 6 pi over 6. Here you can see that 5 pi over 6 is between 3 pi over 6 and 6 pi over 6. So 5 pi over 6 is in quadrant 2, which means negative 7 pi over 6 is also in quadrant 2. So negative 7 pi over 6 is in quadrant 2. That's the coterminal angle and the quadrant which it belongs to. Next, let me introduce trigonometry functions in the xy plane. Let's consider x, y as a point in the xy plane. Also, this point is x, y in the xy plane. Then, the distance from the point to the x-axis is y. This distance is y. And the distance from origin to this point is x. This is x. This is y. This is a right angle. It's a right angle here. Now, how about the distance from xy to the origin? What's this distance here? If I call this side r, how can we find r? We know that this is a right triangle. R is the hypotenuse. If we try to find r, we can use Pythagorean Theorem. R squared equal to x squared plus y squared. Using Pythagorean Theorem, r squared equal to x squared plus y squared. So r is square root of x squared plus y squared. We define r to be positive distance here. R is always positive square root of x squared plus y squared. In general, when we take square root, it could be either positive or negative. But here we define r to be positive. Distance from the point xy to the origin is always positive. We define the distance to be positive. So this is the positive distance from the point xy to the origin. R equal to square root of x squared plus y squared. Let me call this angle theta. Then, based on this triangle here, refer to angle theta. Y is an opposite. X is an adjacent. R is an hypotenuse. So, the trigonometry functions in the xy plane can be defined as the following. What's sine theta? Sine is opposite over hypotenuse. So sine is y over r. How about cosine? Cosine is adjacent over hypotenuse. So cosine is x over r. How about tangent? Tangent theta is opposite over adjacent. So that's y over x. How about cotangent? Cotangent is adjacent over opposite. That's x over y. How about secant? Secant is hypotenuse over adjacent. Secant is hypotenuse over adjacent, r over x. How about cosecant? Cosecant is hypotenuse over opposite, r over y. Cosecant is hypotenuse over opposite, r over y. So those are trigonometry functions in the xy plane. Next, based on this relationship here, we can try to find more special trigonometry values. Next, we'll find special trigonometry values for 0 degree, 90 degree, 180 degree, and 270 degree angles. For sine, cosine, tangent, cotangent, secant, and cosecant. Now, let's first of all look at 0 degree angle. What does 0 degree angle looks like? What does 0 degree angle looks like? If theta is 0 degree, how does a triangle looks like? If an angle theta is very, very close to 0, it looks like this. Assume theta is not exactly 0. Assume theta is very, very close to 0. Assume theta is very, very close to 0. That's angle theta. This is y. This is x. This is r. When theta gets very, very close to 0, y will be 0. Y will be very, very close to 0. This side will be very, very small. When theta is very, very close to 0, this side y will be very, very close, will be very, very small. So when theta becomes 0, y also become 0. How about x? When angle theta becomes 0, x and r will be exactly in the same line. When theta becomes 0, x and r will be exactly in the same line. So x will be exactly the same as r. When theta becomes 0, y approach to 0, and x approach to r. Then sine 0 degree is y over r. Y is 0, we get 0 over r. 0 divided by r is 0. So sine of 0 degree is 0. How about cosine of 0 degree? Cosine is always x over r. When theta approaches to 0, x is the same as r. We get r over r, which is 1. How about tangent 0? Tangent of 0 degree is, in general, tangent is y over x. Here, when theta approaches to 0, y is 0, x is r. We get 0 over r, which is 0. Y approaches to 0, x approaches to r. So y over x is the same as 0 over r, which is 0. How about cotangent 0? Cotangent 0 is x over y. Cotangent 0 is s over y. When theta approaches to 0, y approaches to 0, s approaches to r. So we get r over 0. We know that any number divided by 0 is undefined. Any number divided by 0 is undefined. How about secant 0? We know that secant is always r over x. When theta approaches to 0, x is the same as r, x approaches to r. So you get r over r. R over r is 1. How about cosecant 0? We know that cosecant 0 is r over y. When theta approaches to 0, y approaches to 0. So you get r over 0. Any number divided by 0 is undefined. So for 0 degree angle, sine 0 is 0. Cosine 0 is 1. Tangent 0 is 0. Cotangent 0 is undefined. Secant 0 is 1. Cosecant 0 is also undefined. That's for 0 degree angle. That's for 0 degree angle. Next, let's look at 90 degree angle. Next, when theta is 90 degree angle, let me draw angle that's very, very close to 90 degree. Let me draw a triangle that's very, very close to 90 degree. When theta is very, very close to 90, it looks like the triangle looks like this. When theta is very, very close to 90, the triangle looks like this. This side is R, this side is Y, and this side is X. That's Y, that's X, that's R. And when theta become 90 degree, X will eventually be 0. If theta become 90 degree, X will be 0. So when theta approaches to 90 degree, X approaches to 0. When theta become 90 degree, these two sides will go together. So Y will be the same as R. When theta become 90 degree, these two sides will go together. So Y will be the same as R. That's when theta approaches to 90 degree. X becomes 0, Y becomes R. So sine of 90 degree is Y over R. Sine is always Y over R. Here, when theta approaches to 90, Y is the same as R. So you get R over R. R over R is 1. So sine 90 is 1. How about cosine 90? We know that cosine is always X over R. When theta approaches to 90 degree, S becomes 0. So you get 0 over R. We know that 0 divided by any number is 0. So cosine 90 is 0. How about tangent 90? Tangent is always Y over X. Tangent is always Y over X. When theta approaches to 90, Y approaches to R, X approaches to 0. So we get R over 0. X approaches to 0, Y approaches to R. We get R over 0. Any number divided by 0 is undefined. Any number divided by 0 is undefined. So tangent 90 is undefined. How about cotangent 90? Cotangent 90 is always X over R, S over Y. Cotangent is always S over Y. When theta approaches to 90, X approaches to 0, Y approaches to R. So you get 0 over R, X approaches to 0, Y approaches to R. And 0 over R is 0. How about secant 90? Secant is always R over X. Secant is always R over X. In the coordinate plane, secant is always R over X. And we know that as theta approaches to 90, X approaches to 0. So you get R over 0. Any number divided by 0 is undefined. Any number divided by 0 is undefined. So secant 90 is undefined. How about cosecant 90? Cosecant 90 is always R over Y. When theta approaches to 90, Y approaches to R. So you get R over R. When theta approaches to 90, Y approaches to R. So you get R over R, which is 1. So when theta is 90 degree, sine 90 is 1. Cosine 90 is 0. Tangent 90 is undefined. Cotangent 90 is 0. Secant 90 is undefined. Cosecant 90 is 1. Next, let's look at theta equal 180. When theta is 180, let me draw an angle very, very close to 180. (180) is somewhere here. This is 180. This angle is very, very close to 180. This angle is very, very close to 180. So that's a triangle. When theta is almost 180, that's a triangle. This is R, this is Y, this is X. So when theta approaches to 180, Y will be very, very small. If theta becomes 180, Y will eventually be 0. When theta approaches to 180, Y will approach to 0. And when theta becomes 180, X and R will go together, will become the same side. So X will be the same as R. But this X here is in the negative x-axis. So this X here is negative. So when theta becomes 180, X and R go together, they become the same side. When theta becomes 180, X and R go together. They have exactly the same length. When theta becomes 180, X and R go together, they have the same length. But this X is in the negative x-axis, so it's negative R. This X is in the negative x-axis, so this X is negative. When theta approaches to 180, Y approaches to 0, and X approaches to negative R. Next, let's find the special trigonometry values. For sine of 180, sine is always y over r. In the coordinate plane, sine is always y over r. Y is 0. When theta approaches to 180, Y approaches to 0. We get 0 over r. 0 divided by r is always 0. So sine of 180 is 0. How about cosine of 180? Cosine in the coordinate plane is always s over r. When theta approaches to 180, x approaches to negative r. Negative r over r is negative 1. So cosine of 180 is negative 1. Next, how about tangent of 180? Tangent in the coordinate plane is always y over x. When theta approaches to 180, y approaches to 0, x approaches to negative r. So you get 0 over negative r. 0 over negative r is 0. So tangent of 180 is 0. How about cotangent of 180? Cotangent is always x over y. In the coordinate plane, cotangent is always s over y. When theta approaches to 180, x approaches to negative r, y approaches to 0. We get negative r over 0. Any number divided by 0 is undefined. Any number divided by 0 is always undefined. Next, how about secant of 180? Secant of 180 in the coordinate plane is always r over x. Secant in the coordinate plane is always r over x. And we know that when theta is 180, x approaches to negative r. So we get r over negative r. R divided by negative r is always negative 1. That means secant of 180 is negative 1. How about cosecant of 180? Cosecant in the coordinate plane is always r over y. When theta is 180, y approaches to 0. So you get r over 0. Any number divided by 0 is undefined. So cosecant of 180 is undefined. So here, for theta is 180, we have these values. Sine of 180 is 0. Cosine of 180 is negative 1. Tangent of 180 is 0. Cotangent of 180 is undefined. secant of 180 is -1. Cosecant of 180 is undefined. Next, theta equal to 270. Let's find the special trigonometry values when theta is 270. Let me draw angle theta that's very close to 270 first. Let me first of all draw angle theta, which is very close to 270 first. When theta is very close to 270, it's somewhere here. When theta is very close to 270, it's somewhere here. That's a right triangle. That's a right triangle. So this side is y, this side is x. This is x, this is y. This is a right angle. This side is r. When theta is very close to 270, that's a triangle. This is x, this is y, this is r. Now, when theta approaches to 270, x will be very small. X will eventually approach to 0. If theta becomes 270, x will be very small. X will be 0. When theta approaches to 270, y will be exactly the same as r. When theta becomes 270, y will be exactly the same as r. But when theta becomes 270, this y located in the negative y-axis. When theta becomes 270, this y located in the negative y-axis. So this y here will be negative. So y equal to negative r. Y have exactly the same length as r, but this y located in negative y-axis. So this y is negative. When theta becomes 270, become exactly 270, x approach to 0. Y and r go together. They have exactly the same length, but this y is located in negative y-axis, so it must be negative. That means when theta is 270 degrees, x approach to 0, y approach to negative r. Next, let's find the special trigonometry values. What's sine 270? For angles in the coordinate plane, for trigonometry values in the coordinate plane, sine is always y over r. Here, y is negative r. When theta is 270, y is negative r. We get negative r over r, which is negative 1. When cosine is 270, for cosine in the coordinate plane is always x over r. When theta approaches to 270, x approaches to 0. We get 0 over r. 0 over r is always 0. Next, let's find tension 270. Tension in the coordinate plane is always y over x. When theta is 270, y is negative r, and x is 0. Negative r divided by 0 is always undefined. Any number divided by 0 is undefined. How about cotension 270? For cotension in the coordinate plane, that's always x over y. That's x over y. When theta approaches to 270, x is 0, y is negative r. We get 0 over negative r, which is 0. How about secant 270? Secant in the coordinate plane is always r over x. When theta approaches to 270, x approaches to 0. We know that any number divided by 0 is undefined. Here, r divided by 0 is undefined. So secant 270 is undefined. How about cosecant 270? What about cosecant 270? For cosecant in the coordinate plane, it's always r over y. Cosecant in the coordinate plane is always r over y. when theta is 270, y approaches to negative r. So you get r over negative r. R over negative r is negative 1. So those are the special trigonometry values when theta is 270. Sine of 270 is negative 1. Cosine of 270 is 0. Tangent of 270 is undefined. Cotangent of 270 is 0. Secant of 270 is undefined. Cosecant of 270 is negative 1. So those are some special trigonometry values for 0-degree angle, 90-degree angle, 180, and 270-degree angles. Memorize this table.